Hi friends, welcome back. Today we're talking about uniform motion problems about equal distance. Now these are the common problems that you see like on the SATs or even as like jokes. If this train left the station going northbound and this other train left 2 hours later going southbound, those kinds of problems. These ones though are going to be about equal distance. Now, what you need to remember here are two things. One, this table is going to be really helpful. I did a terrible job of drawing right here. The other thing you need to remember is that distance equals the rate times the time. So that is going to be, or in how we normally write that is distance equals rate times time, like that. And that is going to be really helpful here. The other thing we're going to be working with are subscripted variables. So it's good we've been practicing on those. So what you want to do when you have a distance problem like this is start each problem with your table. So you'll see that I've got my table right here for our first example. Okay, so let me go like this. The reason why I split this up and I do it like either a little bit halfway or either halfway or a little bit lower is because when I'm done, I want to be able to go write my answers back in so that I can write my complete sentences. So let's go through this and figure out what we've got. On Tuesday, the express train made a trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. Whew, that sounds like a doozy straight off the bat, but these tables are going to be super helpful. So this is going to be the express train, right? And this is going to be the freight train. I don't even know how to spell freight. Did I do that right? There we go. So the freight train. Okay, yes, I did. All right, let's go through item by item and see what we can come up with. On Tuesday, the express train made the trip in 12 hours. That's easy peasy. We have distance equals rate times time. If it helps, we can do distance equals rate times time. Well, we know the express train did it in 12 hours. So I'm going to put 12 right here. On Wednesday, the freight train made the same trip in 16 hours. There's actually two pieces of information here. We have the 16 hours. We also have same trip, which means that our distance of the express train is the same as the distance of the freight train. I didn't mean to write it over there. I actually want to write it down here. Is the same as the distance of the freight train. So what that means is distance of the express train, and we don't know what that distance is yet, right? So we're going to use some variables here. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. So whatever the express train is, whatever the rate of the express train is, the freight train, RF, was RE, was the rate of the express train minus 16 or minus 15, I keep saying 16, minus 15. So the freight one was whatever the express was, take away 15. Now, remember, distance equals rate times time, so we're going to write out our equation here. We have DE equals RE times 12. And to make it nice and clean, I'm going to write 12 RE. DF equals, and remember to use your parentheses because we've got a statement there, 16 times RE minus 15. Okay, so what we're going to do with that information is we're going to write a couple of equations here. Equals 12 RE. And then on this one, we're going to say DF equals 16. Actually, what I'm going to do here is just distribute to make my life easier. So we get 16 RE minus whatever 16 times 15 is. We end up with 240. Okay, so now we've got some substituting we can do. Well, if we know DE and DF are the same thing, well, what I can do is rewrite this guy as DF equals 12 RE, because all I did was substitute in. I took DE, I substituted this garbage in for this guy right here. Now that I know DF equals this, what I can do is take that information and plug that in right here for that DF. So I get 12 RE equals 16 RE minus 240. Oh, my eyeballs itch. Okay. Then we're going to minus 16 RE from each side, minus 16 RE. So we end up with negative 4 RE equals negative 240. Divide both sides by negative 4. Negative 4 RE equals 60. positive 60. Okay, so now that we know RE, let's take that and substitute back in for that guy right up there. So DF equals 12 times RE, which is 60. And 12 times 60, 720. I don't know why I was having a brain fart there. So that's 720. So if DF is 720, DE is also 7, because all I'm doing is taking this number and substituting it up here. This is also 720. So why do I have this table here? That is really helpful if we have, I lose my pens. What's going on? Okay, so now what I know is RE is 60, and RE stands for the rate of the express train. So the rate of the express train is 60 kilometers per hour. Now, if the rate is 60 here, remember our freight train was 15 less than that. So if we do 60 minus 15, we get 45 kilometers per hour. The distance of the, so DF right here is 720 kilometers. We are talking kilometers, right? Yeah, because everything says kilometers. So kilometers, and because they are the same, right? This is also 720 kilometers. I forgot my little M here. Okay, so I paused the video so that you didn't have to see me write a whole sentence, but I do think that it's vitally important that you write, when you're doing these distance, rate, and time problems, that you write your answer out completely. And so what that would look like is we would take the information from our box up here and say, the express and freight trains both traveled 720 kilometers. The express train traveled at a rate of 60 kilometers per hour. The freight train traveled at a rate of 45 kilometers per hour. Now, again, it says find the rate of each train. So we found the rates of each train, but I also threw in that they traveled 720 kilometers. This is a good idea just to keep that excess information in your answer, because if you're consistent in how you do these, it becomes a lot easier. Okay, so let me find the next one. Okay, so here's our next question. The members of the club hiked to Lake Tenkiller at 2 miles per hour. Mr. Alley gave them a ride back home at 12 miles per hour. For their hiking time, if it was 5 hours longer than their riding, find their hiking time if it was 5 hours longer than their riding time. How far was it to Lake Tenkiller? Again, that's a lot of information. Here's what we know. They hiked, so we're going hiking and then we are driving, right? So hike and then ride are our two things here. So we have hike and then ride. All right, so the members of the club hiked to Lake Tenkiller at 2 miles per hour. So that's our rate, right? So 2 miles per hour. Mr. Alley gave them a ride back home at 12 miles per hour. Find their hiking time if it was find their hiking time if it was 5 hours longer than their riding time. So the time for riding, whatever that was, if we take that and we add 5 hours to it, we get our hiking time. So the time for riding plus 5 hours gives us that time for riding, or time for hiking. Now, the thing that we're missing is the distance. Well, you kind of have to envision it like this. They started at this point, they went to the lake. Here's my lake. I'm gonna draw, you can use a better pen. That's annoying me. Okay, so there's the lake that we have there. And then when they came back, right? So, that's gonna be a disaster. They go walking like this. So you'll see that they have the same distance. So the distance hiking and the distance riding. That can be our first equation here. Distance hiking equals the distance riding. Now, taking a look at our information, remember our equation is distance equals rate times time. So DH equals, and if you have addition or subtraction, we put it in parentheses. So 2 times TR plus 5. DR equals 12 times TR. Okay, let's write those guys down. We have DH equals 2TR. I'm distributing as I do this, so I get plus 10. And then DR equals 12TR. Okay, so the first thing that we know is DH and DR equal each other. So what I can do is say DR, I'll use this one because it's a little smaller. This is going to be DH equals 12TR. So now that I know dH equals all this garbage, what I can do is say, okay, it equals all this garbage right here. Take that and plug it in right over there. So now I have 12TR. That is an R there. It's kind of hard to see. Equals 2TR plus 10 minus 2TR minus 2TR. And I get 10TR equals 10. Divide both those by 10, you get TR equals 1. Okay, now that I know TR equals 1, let's go ahead and put that over here. DH equals 12 times 1. So DH equals 12. DH equals DR, so 12 equals DR. So let's take all that information and plug that back into our table so that we can figure it all out. We know TR is 1, and that is time, so it's going to be hours. Now remember, TR is 1 plus 5. That's going to be 6 hours. So we have 6 hours there. Now, we already know our rate here, and then our DH is 12, and our DR is 12. So this is going to be 12 miles and 12 miles. Okay. All right, so just a reminder, I like for you to answer word problems in a complete sentence, and especially with these, you can answer with excess information. So the members traveled a distance of 12 miles both ways. It took them 6 hours to hike and 1 hour to drive. If we go back and look at the question, it says how far was it to Lake Tenkiller? So the members traveled a distance of 12 miles. So it was 12 miles away. And so that second sentence isn't totally necessary, but it is a really good idea to have that there. All right, so for our next one, let's take a look. Durant drove to the oasis in 2 hours and Medill walked to the oasis in 10 hours. How far is it to the oasis if Durant drove 16 miles per hour faster than Medill walked? Why didn't he give his friend a ride? Come on. All right, so we've got this drive, and walk. So Durant drove to the oasis in 2 hours. So the time for Durant was 2 hours. Medill walked to the oasis in 10 hours. How far is it to the oasis if Durant drove 16 miles per hour faster than Medill walked? So whatever the rate was for walking, the rate for driving was the rate for walking plus 16 miles per hour. Okay, so then we have the distance for driving, the distance for walking. So we have our equation here. Distance for driving equals this times this, so 2 times RW plus 16. The distance walking equals 10 times RW. Okay, so we have those guys out. Now we also know that our distance is the same. They drove to the oasis from the same spot and got to the oasis. And then the other guy walked. So it's a little bit different because this one, the arrows go both ways, but it means that the distance is the same. Hence the name of this unit, by the way, uniform motion problems about equal distances. That's why this one goes one way and then the other. Doesn't matter. They're still equal distances. Okay, so if we come up with some equations now, that means we know DD equals DW. We know this guy right here, DD equals, I'm going to distribute 2RW plus 32. DW equals 10RW. Okay, if DD and D up, so this, I'm going to just replace this with DW equals 2RW plus 32. And now if we know this is DW and we know DW is 10RW, we can just substitute that in. 10RW. So I took this garbage here, plugged it in for that there because these guys are equal. Equals 2RW plus 32 minus 2RW. Sorry, I'm squishing that in there. 2RW. 8RW equals 32. Divide by 8. Divide by 8. RW equals 4. Okay, now that we know RW equals 4, we can come up here. DW equals 10 times RW, which we now know is 4. So DW equals 40. DD equals whatever dw is, which is 40. So let's go back and write this all in. dd and dw are both 40, and we're talking miles. So 40 miles, 40 miles. The rate rw is 4, so this is 4 miles per hour. If this is 4 miles per hour, we've got to add 16 to that, so we get 20 miles per hour. Okay, so it says, how far is it to the oasis if Durant drove 16 miles per hour faster than Medill walked? So how far is it to the oasis? It is 40 miles away from the away to the oasis, and they walked at a rate of 20 miles per hour. I'm sorry, walked at a rate of 4 miles per hour and drove at a rate of 20 miles an hour. Okay, so here are the practice problems. Pause the video, do those, and then come on back. Okay, so for these practice problems, you should have gotten 18 miles for A and 360 miles for B. If you did not, let me know, and or not let me know, stick around and we'll do them together. Okay, let me move my little face out of the way. All right, so the first one says, Candide and Pangloss walked to the site of the disaster in 9 hours. The next morning, they jogged back home in 3 hours. How far did they jog if they jogged 4 miles per hour faster than they walked? So they walked this way, and then they jogged back home. So our distances are going to be the same again. We have walk, and we have jog. So let's go back and see. They walked to the site of the disaster in 9 hours. The next morning, they jogged back home in 3 hours. Woof, they're fast joggers. How far did they jog if they jogged 4 miles per hour faster than they walked? So whatever their rate was walking, their rate jogging was the rate walking plus 4 miles per hour faster. So we have dw and dj. So again, our equations are going to be dw equals 9 times rw. And we have dj equals 3 times rw plus 4. Okay, so the first thing that we know is the distance walking equals the distance jogging. Then we have the distance walking equals 9 times the rate of walking. And we know that the distance jogging equals 3 times the rate walking plus 12. I went ahead and distributed from here to here. Okay, so dw equals dj. So instead of dw here, I'm going to put in a dj since they are equal to each other. Let me use my whiteout here. Made that significantly bigger than it needed to be. All right, so dj equals 9 rw, which means we can plug that bad boy right into here. All we got to do is take this and be like, bam, go right there. So we go right there. We're like, okay, that's 9 rw. I know you're thrilled to be doing this. You're like, yeah, that's going to be so exciting. All right, let's minus 3 rw from both sides. We end up with 6r. W equals 12. Divide both sides by 6. We get r. W equals 2. dj equals 9 times rw, which we now know is 2. So dj equals 18. And dw equals whatever dj is. So that's 18. So let's go ahead and answer our questions. We got dw is 18 miles because we're talking about miles. dj is also 18 because it's the same distance, 18 miles. The rate rw was 2, so this was 2 miles per hour, and then they jogged this at the rate that they walked plus 4. So 2 plus 4 gives us 6 miles per hour. So they walked the distance. So the question asks, how far did they jog if they jogged? Okay, so they jogged 18 miles. That's where we get the 18 miles. At a rate of 6 miles per hour. They walked the same distance, 18 miles, at a rate of 2 miles per hour. All right, let's do this next one. On Monday, Voltaire drove to town at 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. If the total traveling time for both trips was 15 hours, how far was it to town? Okay, so let's take a look at this guy. We have Monday and then Tuesday. So here's Monday. Here's Tuesday. Let's go through and put this information in. He drove to town at 60 miles per hour. So the rate on Monday was 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. So here's his house. And he drove to town. I don't know how to draw a town, so we're just going to put it. And then I don't care about when he went back, but then so this is Monday, and then on Tuesday, he made these same drives. So again, our dm and dt are going to be the same. We can even start that out. dm equals dt. Now, this is going to be, that's a d. This is going to be tricky. If the total traveling time for both trips was 15 hours, so on Monday, if we have time for Monday, Tuesday is going to be 15 hours minus whatever Monday's time was. If it took him 1 hour on Monday, then Tuesday would be 14, because together those things have to equal 15. So that gives us dm equals 60 tm, dt equals 40 times 15 minus tm. Okay, so we have some equations here that we can write down. dm equals 60 tm. dt equals 40 times 15, 600, minus 40 tm. Okay, so now that we know this, dm is the same as dt. So let's write this. dt, I'm just substituting it in for dm, equals 60 tm. So now that we know dt is this, what I can do is take this guy zoink, zoink, right here and plug him in right there. So that's going to be 60 tm equals 600 minus 40 tm. Add 40 tm to both sides. And we get 100 tm equals 600. Divide both sides by 100. Lob off some zeros. We get tm equals 6. Okay, so let's go back and write in our information. Oh wait, now that we know tm is 6, so we go dt equals 60 times, and instead of tm, we're going to put in 6. So we get dt equals 360. And because dt equals 360, so does dm, 360. Okay, so tm is 6. So this is going to be 6 hours. Yep, just making sure. And then 15 minus 6 would give us 9 hours. And that makes sense because he drove 60 miles an hour and then he drove 40 miles an hour. So there's going to be a pretty significant, it's going to take him a little bit longer. And then the distance that they went was 360 miles. So a sentence that you might use, or two sentences for your answer, is it is 360 miles to town. On Monday, it took him 6 hours, and on Tuesday, it took him 9 hours. All right, if you have any questions, leave them below. Otherwise, great work, and we'll see you next time.